Now to test what you can with the board at this stage, you're obviously going to want the ESP32 Pico kit, the SD card. You're going to need a USB power source. It would be even better if you had this connected to a PC running a terminal emulator so you can look at the console logs from the ESP32. And you're going to want the test lead that I supplied, or in fact you can use the power switch because the switches and the holes in the circuit board are designed to have a slight press fit, so they'll make enough contact to do the job. So I'll demonstrate it both ways. So let's get things mounted. We'll put the ESP32 in, remembering the Wi-Fi antenna goes towards the RS-232 connectors and the USB towards the outside of the circuit board. Micro SD card in place. Now we can apply power. There may be a random flash of LEDs when it first powers on, and then the LEDs should go out. At this point, the IMSA8080 ESP believes that it's turned off because it's not sensing the power switch in the on position. Okay, the simplest way to test the IMSA8080 ESP at this point is to get the power switch, the lugs on the power switch, and the through holes on the circuit board should just be a slight press fit, so they'll make contact enough for this test. Put the power switch in place, make sure you've got your power source connected and the power switch in the down or off position. Reset the IMSA8080 ESP, and now it believes it's in the off position. When we turn on the power, we'll see some of the lights come on. This is the halt light. The machine's not in the running state when it's first powered up, but we can fix that problem with the test lead that I provided. On switch S3, which is the run stop switch, shorting out the center pad and the lower pad, we'll put the machine into the run state. The run light comes on. What we're seeing on the other LEDs is probably just garbage because RAM is filled with random values. It's trying to run a program, who knows what it's encountered. It may even have crashed, but if it hasn't, we should be able to use the test lead to now, again on S3, short out the center and top pad, and we return to a halt state. So we can just chop and change back and forward from run to halt and back again. This is a good sign that at least these switches are working. The LEDs are generally working, and we tested them all earlier in the build process. So things are looking good. The power switch turns it off, turns it back on. Not bad. I guess a final test worth making at this point is with the power switch turned on. Move to S4, which is the reset switch position. And by shorting out the center and bottom pad, that's the same as holding the reset switch on. All the LEDs should light up. So it looks like I've got a problem with LA11. I'll have to investigate what's happened there and get that fixed. Hopefully it's just a dry solid joint. Because yes, certainly at that point, I'd be expecting to see all the LEDs on. So I'll just fix that up and come back and show you that again. Right, well, as you can see, I've replaced LA11, and that really couldn't have been any harder. When I had a look at the LED, it had a sort of slightly black appearance in the lens compared to the other LEDs around it. I'm just trying to find out what I did, see what I did with it. So I chose to cut it out. And when I had a look underneath, you're not going to see this in shot, I'm sure, but there was a sort of suspicious blackness around one of the leads as it enters the LED plastic casing. So clearly something had gone wrong with that LED, and thankfully there was a spare one that I ship in the kit. So I was able to replace it. If you did end up destroying more than one or having a fault with more than one LED, please let me know and I'll arrange to get another one to you. They are a specific strength, 200 milli candelas, and you might find them hard to match at a high street electronic suppliers. So I had to desolder all of the leads that were left in the board. I checked the resistor with my multimeter and it was in good health. So I replaced the LED, but things got worse because in the process, remember that was the IC that I'd already bent another pin, and that was unrelated to the behavior of LA11. And in the process of removing and reinserting this IC, I managed to break off the pin in the corner here that I'd earlier bent. So that's pretty much a worst case scenario. Luckily, these are kind of a regular and easily sourced part. Standard 7.4 series integrated circuits. They are the HC series, so you want to get the same 74HC 595. So I've got a lot of stock on hand at the moment, so that was easy for me to replace. But for you, that might be a little bit annoying if you manage to do that to one of your ICs until you can source another one. All right, so LA11's back in order. We'll just quickly test that. Powering up the PCB using the test lead, and we'll just short from that IC pin to where power is on this capacitor. Let's pick the right pin, third pin in from the end. You can see the trace leading up to the resistor, and that's LA11 lighting up. Excellent. So now we can go back to putting in the power switch, resetting the board, powering on, and that test I was demonstrating is we are in switch S4, shorting the pad in the middle with the pad at the bottom, which is equivalent to lifting the reset switch, and we see that all the LEDs are on success. Or all of the data and status LEDs and address LEDs are on. So next will come layering up the switch plate, the large black sheet of acrylic mounted on top of the PCB, just those two with the 9mm spaces between them, and we'll get started on soldering in our nice red and blue toggles. But for now, switch it off and we're done.